All right, let's jump into number 4. So definitely still in the world of linear speed and angular speed, so we should still be thinking about all of those equations and kind of how we solved the last problem, but this one's going to be a little bit different. So let's look at what we're given. So we're given a bike with tires 26-inch diameter, so that means my radius is 13. The bike is going 18 miles per hour. That seems pretty fast. But let's mark that with a V for linear speed, right? Miles per hour is a linear speed. And it wants us to find the angular speed in radians per minute. Whoa, crazy, because I have my linear speed in miles per hour. So I'm going to definitely need to do some converting. So let's set up my equation here. I have linear speed, I have my radius, and I want to solve for angular speed. So my linear speed is 18 miles per hour, and my radius is, issue, because my radius is in inches. So I need to convert from inches to miles, because otherwise I can't use them both in the same equation, right? So let's do a little converting here. Here it is. We were remembering this a little bit more now. So again, I'm trying to convert inches into miles so that I can use my equation here. So I think once you multiply this out and divide, you get kind of a funky answer. You'll get 2.05 times 10 to the negative 4, right? That's what that E means. So it looks ugly, but just hang on to that for a second. And let's plug that into our equation. 2.05 times 10 to the negative 4. What a great chance for us to practice our scientific notation. So I'm moving my decimal place to the left 4 spaces. So this is 1, 2, 3, 4, right? So how many zeros am I going to have? 3. So this would be 0.000205 miles times my angular speed, right? And solving that out, we would just divide both sides by this icky looking number. And there are definitely different methods to solve this. This is just the one that stood out to me, but of course, there are other methods. So if you're like, wait a minute, this isn't how I thought about it, you might just check your answer at the end and see if it matches. So this is what I get when I solve for my angular speed. And since this is per hour, this is going to be in radians per hour. Now, do I want it per hour? No, I want it per minute. So then my last step here is going to be to convert from hours to minutes. So it looks like I just divide that big answer by 60, and I get 1,462.15 for my radians per minute. There's definitely, I can think of 2 right off the top of my head methods to solve this one. So please, if you did it a different way but still got to about that same answer, I would definitely say that that is probably a very correct pathway and good for you for finding an alternate route. Awesome. Okay, part A, check. I think we're going to need that answer because now I'm just converting it to be rev per minute. So let's go back and remember what the heck my angular speed was. Okay, 1462.15. And again, that was radians per minute. And it looks like I just want to convert it to be revolutions per minute. So I just need to get rid of radians. Well, that's easy enough. I'm going to put my radians down below here, and that will be 1 revolution. So it looks like I'm just dividing that answer by 2 pi, and I get 2,296.7 RPMs, revolutions per minute. Now, again, you could have left this answer in pi. That's what I typically do, but this problem here was getting a little bit too crazy. I just decided to multiply and get a decimal, and then since I already had a decimal, I just decided to divide by 2 pi instead of just 2 and leaving my answer in terms of pi. But if you did that, you should just have a pi in your denominator here. And I can check that answer if you're unsure if it's correct. But this is what we should get here, RPMS. Awesome. So that is number 4. Right, with the time left here, I'd like to touch on number 5. So we are going from radians to degrees. So the shortcut here is remembering pi equals 180 degrees. So to convert from radians to degrees, I multiply by 180 over pi. From radians to degrees, because we want our pi's to cancel. Right? Now, these cancel out, and 180 divided by 3 is 60 degrees. Hopefully we kind of know that from the unit circle, but that's how you would do that. So that's method number 1 of how to do this. How to convert 2 degrees, method number 1. Method number 2 is substituting in 184 pi. Now that's a method I know a lot of us really enjoy using. The only problem with that method is if you're given radians as a decimal, that's obviously not going to work. But if you are given radians in terms of pi, this is a real quick, nice way to figure out what your degrees are, right? Because right away, I can do 180 divided by 12, right? And that's going to give me 15. And then 15 times 7 is just 105 degrees. So again, it's okay if you use a different method, but you should get to that answer eventually. So we have 2 methods here. Whichever one you'd like to use on part C, you should get negative 45 degrees. For part D, you should get 480 degrees. So that's over 1 revolution around our unit circle. And then in part E, the method we have to use is multiplying by 180 divided by pi, right? There's no other way for us to do this one. So if you just type that right into your calc, I get 315 over pi, which is about 100.3 degrees. 100.3 degrees. So in part A, you should get, what happened there? 60 degrees. In part B, you should get 105. In part C, negative 45 degrees. Part D is 480. And then last but not least, 100.3 degrees. Awesome. So next, to go from degrees to radians, what you want to do here is multiply by pi over 180. So 240 times pi over 180. So I would just cancel out these zeros. Think about what is 24 divided by 18. Can I simplify that? Yes, you can. is going to be 4 pi over 3 radians. And I would encourage you to leave your answers in terms of pi. In part B, I have a negative, but do not fret. That's okay. I can still multiply it by pi over 180. And if you simplify that out, you should get negative 3 pi over 4. So if it's a negative, just make sure your final answer is also negative. 270, we should hopefully just know that from our unit circle that that's 3 pi over 2. But you could do it the same method. For 75 degrees, again, just multiply it by pi over 180. And what you should get there is going to be 5 pi over 12. Simplifying that out, negative 2 degrees, little baby angle. And we would just get negative pi over 90, right? Simplifying that. Awesome. So those are my answers. One thing I will share is one way some people like to do it is using a proportion. So for example, in part A, you could write 240 over 360 is going to be the same thing as whatever 240 is in radians over 2 pi, right? And then you could cross multiply and then divide by 360. So some people do like to do it that way. I kind of forgot about that method. Same thing over here, setting up your proportion for part A. It does get a little trickier because I kind of have fractions on top of fractions. But if you are a proportion person, that will also work. So again, just cross multiply this times this, and then you divide by 2 pi, and that will also give you the correct answer. So I hope you enjoyed this video. I hope you found it helpful. Please reach out if you need more help. Good luck.